1. The universe has no center. When we gaze into the vastness of the universe, it's natural to wonder where it all began, where its heart might be. Yet the universe defies this instinct. Contrary to what one might assume, the universe does not have a center. It isn't expanding like an explosion from a single point, but rather it's stretching from within, equally and everywhere. Imagine blowing up a balloon with dots scattered on its surface. As the balloon expands, each dot moves away from every other dot. No dot is the central point. That's how our universe expands, not from a location, but as an unfolding of space itself. This idea is comforting in its strangeness. No matter where you are in the universe, it appears to you that everything is moving away from you. It creates the impression that you are at the center, even though every point in space feels exactly the same. In this way, the universe treats all locations equally. There is no preferred spot, no chosen place. When we apply this cosmic truth to our personal lives, it can offer a strange kind of peace. We often look for direction, purpose, or meaning from an external center, something solid to hold on to. But just like the universe, life doesn't have one fixed center. Each of us is free to be the origin of our own perspective. We don't have to chase some faraway meaning. We are allowed to feel like the center of our own experiences because, in a way, we are. Let this thought settle gently in your mind as you prepare to rest. You are not lost in the cosmos. You are woven into its very structure, inseparable from its expansion, its growth, and its quiet rhythms. The universe has no center, and yet you are exactly where you need to be. 2. You are made of stardust. There's something quietly beautiful about knowing that everything you are, your body, your breath, your thoughts, originated in the heart of a star. The atoms that make up your skin, bones, blood, and mind were not formed on Earth. They were born in ancient stars that lived and died long before our planet ever took shape. In the cores of these stars, nuclear fusion turned hydrogen into helium, and then into heavier elements like carbon, oxygen, and iron. When these massive stars reached the end of their lives, they exploded in colossal supernovae, scattering those elements across the galaxy. Those scattered ingredients floated through space, mingling with gas and dust, until gravity slowly pulled them together again, forming new stars, new planets, and eventually, life. You are quite literally made of the dust of stars, the calcium in your teeth, the iron in your blood, the carbon that forms your DNA. All were forged in the fires of distant suns. This isn't just a poetic image. It's a scientific fact, confirmed by the way we observe elements forming in stellar cores and supernovae remnants. When you reflect on your worries, your day, your doubts, pause to remember this truth. You are not small. You are vast. You carry in your body the memory of ancient stars. You are the living echo of explosions that happened billions of years ago. Even the breath you take, filled with oxygen, was once part of a cosmic cycle that predates humanity by aeons. This realization can bring comfort when life feels overwhelming. It means you are not an outsider to the universe. You are part of its story, its chemistry, its endless cycle of death and rebirth. Stardust is not just something in the sky. It's you. Tonight, as you breathe in and out, allow yourself to feel that connection. Your heartbeat is older than time as we know it. The particles that form your body have traveled across space and through time. And now, they rest within you, glowing quietly like embers of forgotten stars. 3. Most of the universe is invisible. When we look up at the night sky, it's easy to think we're seeing the whole picture, a blanket of stars, galaxies, and distant planets. But what we see is only the surface. In truth, more than 95% of the universe is invisible. The stars, planets, gas clouds, and light we can detect only make up a small fraction of all that exists. What remains unseen is made up of two great cosmic mysteries: dark matter and dark energy. Dark matter accounts for about 27% of the universe. It doesn't emit light, doesn't absorb it, and can't be seen directly. Yet we know it's there. Its presence is felt in the way galaxies rotate. If only visible matter existed, galaxies would spin themselves apart. But they don't. Something else holds them together. That something is dark matter. Then there's dark energy, even more elusive. It makes up about 68% of the universe and is believed to be the force behind the universe's accelerating expansion. It's not something we can touch or see, but its effects ripple through space like a silent current, steadily pushing galaxies farther and farther apart. Altogether, this means that the universe we understand is just the tip of a cosmic iceberg. Like trying to comprehend an ocean from a single drop, we see only a small part of the greater whole. The vast majority of what exists remains unseen, untouched, and perhaps even unknowable, for now. But that isn't frightening. It's soothing, because it tells us there is still so much left to discover. There's magic in what we don't understand, beauty in mystery, and wonder in the unknown. It means the universe is not limited by what we can observe. It is full of potential, and so are we. In the same way that most of the universe is invisible, so are many parts of who we are, our hopes, our memories, our quiet thoughts. But they are real. Just because something is unseen does not mean it is unimportant. Let that thought settle in your heart tonight. You are surrounded by mystery, and you are made of it too. 4. Time moves differently near massive objects. Time is not as fixed or constant as it seems. Instead, it ebbs and flows, influenced by the presence of mass and gravity. This concept, first revealed in Einstein's theory of general relativity, tells us that the more massive an object is, the more it warps the fabric of space-time around it. And in those regions of strong gravity, time slows down. Picture this. You're floating in deep space, far from any stars or planets. Time ticks forward at its usual rhythm. But now imagine approaching a black hole, one of the most massive and dense objects in the universe. As you draw closer, the very fabric of time stretches. To an outside observer, your clock appears to slow. If you hovered near the event horizon, the boundary beyond which nothing can escape, time would almost stop altogether. 1 minute near a black hole could equal years or centuries elsewhere. This phenomenon, known as time dilation, isn't just theoretical. We've observed it in real-world experiments. Satellites and astronauts in orbit experience time slightly slower than we do on Earth's surface, thanks to the weaker gravity up there. While the difference is minuscule, it's real, and it has to be accounted for in GPS satellites, or their timing would slowly drift. Contemplating the relativity of time brings a gentle kind of peace. It reminds us that time is not a rigid master, but a flowing river, bending to the contours of gravity and speed. It tells us that in the vastness of space, time can stretch and breathe, unbound by our human schedules. Let that thought settle into your mind. When you feel rushed or pressured by the clock, remember that time itself is far more flexible than we perceive. You are not late. You are flowing with the current of the cosmos, a rhythm that gently shifts with every heartbeat of the universe. 5. Space is completely silent. When you look up at the stars and imagine supernovae erupting, stars colliding, or entire galaxies brushing past one another, you might picture those events as loud, thunderous affairs. But in space, they occur in total silence. That's because sound needs a medium to travel through, like air, water, or solid ground. Sound waves are mechanical vibrations, and without particles to carry them, they simply cannot exist. Space, being nearly a perfect vacuum, has no atmosphere to transmit sound. So even the most spectacular, violent, or magnificent events unfold in absolute quiet. The silence of space is not a void, but a canvas for other forms of communication. Light, radiation, and gravitational waves travel across the cosmos, carrying whispers of celestial happenings to us. Instruments like radio telescopes convert those signals into sounds we can hear, echoes of pulsars, the faint hiss of cosmic microwave background radiation, the gentle rhythm of orbiting stars. These are not the true voices of space, but translations, interpretations. There's a kind of comfort in that silence. While our world is filled with noise, machines, conversations, movement, the universe continues in a quiet, patient stillness. It doesn't rush. It doesn't shout. It unfolds in a serene rhythm, unhurried by the concerns of sound. When you feel overwhelmed by the noise of daily life, think of space. Think of that deep, infinite quiet. Imagine yourself floating there, weightless, surrounded by stars that shine without a sound. Let the peace of that silence fill your mind. Let it still your thoughts, calm your heart, and remind you that silence, too, is part of the music of the universe. 6. There are more stars than grains of sand on Earth. Imagine walking along a beach and scooping up a handful of sand. Now imagine counting every single grain. Then, imagine counting every grain of sand on every beach and in every desert on the entire planet. That's an unimaginable number. And yet, scientists estimate that there are more stars in the observable universe than there are grains of sand on Earth. The Milky Way alone contains up to 400 billion stars, and that's just one galaxy. Recent estimates suggest there could be as many as 2 trillion galaxies in the observable universe. Multiply those together, and you arrive at a number so vast it defies comprehension. Something in the range of 10 to the 24th power stars. Each of those stars could have planets orbiting it. Some may have systems with multiple suns. Some may host life. Some may have civilizations, oceans, mountains, or clouds made of methane. Some might be utterly dark and cold, and others might burn brighter than anything we've seen. And yet, from Earth, under the night sky, we see only a tiny sliver of them, a few thousand visible to the naked eye, just the barest whisper of all that's out there. This staggering scale might seem overwhelming, but it can also be deeply calming. In the grand sea of stars, our worries shrink, our anxieties fade. We realize that while we are small, we are also part of something incomprehensibly vast. We are witnesses to a universe overflowing with stars, each one a tiny light burning softly in the dark. You are not alone. You are surrounded by stars. 7. A day on Venus is longer than a year. Venus, our nearest planetary neighbor in the solar system, is a world of extremes. It's about the same size as Earth, but its conditions could not be more different. Covered in thick clouds of sulfuric acid and with surface temperatures hot enough to melt lead, Venus is inhospitable to life as we know it. But one of its most intriguing features has to do with time. A single day on Venus, the time it takes to complete one full rotation on its axis, lasts about 243 Earth days. Meanwhile, Venus completes one full orbit around the Sun in only about 225 Earth days. That means a day on Venus is longer than a Venusian year. To make things even more fascinating, Venus rotates in the opposite direction of most planets in the solar system, including Earth. So, if you could stand on its surface, which you couldn't due to the crushing pressure and intense heat, you would see the sun rise in the west and set in the east over the course of many Earth months. This strange timing offers a quiet lesson. Just because something moves slowly doesn't mean it isn't moving. Venus teaches us that time flows differently depending on perspective. In its slow, deliberate rotation, it offers an alternative rhythm, one that defies our expectations and invites reflection. In a world where everything seems to be moving faster, Venus reminds us that slowness is not a flaw. Sometimes the most profound changes and movements happen gradually. Let this thought comfort you as you drift into rest. There is time, there is space, and your own rhythm is just as valid as the stars. 8. The light from distant stars is ancient. Every time you look up at the night sky, you are seeing the past. Light takes time to travel, even at its incredible speed. When you look at the moon, you see it as it was 1.3 seconds ago. The light from the sun takes about 8 minutes to reach Earth. But the light from distant stars, that light has been traveling for years, centuries, even millennia. Some of the starlight you see tonight left its source before humans invented the wheel, built pyramids, or wrote down language. That light has been crossing the void of space, unbothered, unhurried, faithfully making its way to you. It has traveled through dust clouds, past galaxies, and across unimaginable distances to softly touch your eyes tonight. Even the faintest glimmers in the sky, those tiny points of light barely visible, could be from stars so far away that their light has journeyed for millions of years. And some of those stars may no longer even exist. They may have gone supernova, collapsed into black holes, or faded away, but their light is still on its journey, still arriving. In that way, the night sky is not just a view. It's a memory, a living time capsule, a message in a bottle sent across the ocean of the cosmos. So when you look up tonight, know that you are receiving something ancient, something sacred, something made of both light and time. Let that fill you with quiet awe and peace. Even when things are gone, their light can still reach us. 9. Our galaxy will merge with Andromeda. Far beyond the reach of everyday concern, the universe is choreographing a slow and graceful encounter. The Milky Way, the spiral galaxy we call home, is on a quiet collision course with its neighbor, the Andromeda Galaxy. But unlike the fast and chaotic collisions we imagine on Earth, this galactic meeting will be peaceful, poetic, and stretched across billions of years. Andromeda is currently about 2.5 million light-years away and approaching us at a steady pace of roughly 110 kilometers per second. That might sound fast, but in cosmic terms, it's a gentle drift. Scientists estimate that in about 4 billion years, our galaxies will begin to interact, slowly spiraling around each other, their shapes warping as stars are nudged into new orbits. Despite the enormity of these galaxies, each containing hundreds of billions of stars, the likelihood of actual star-on-star collisions is minuscule. Stars are separated by such vast distances that they'll pass each other in the night like ships at sea. Instead of crashing, the galaxies will dance. They will weave and merge, reshaping into a single, larger elliptical galaxy, a majestic result of cosmic grace. And here's the most soothing part. Earth and our solar system will likely survive this dance relatively undisturbed. By the time the galaxies have settled into their new form, the skies above Earth may glow with a breathtaking light, swirling arcs of starlight painting the heavens, a new cosmic ceiling. This gentle merging is a reminder that even dramatic change can unfold slowly and with beauty. It teaches us that transformation doesn't always have to be violent or sudden. Sometimes the most profound shifts in life happen quietly, patiently, over time. So as you drift towards sleep tonight, imagine galaxies gliding toward one another through the black, vast sea of space, each curve and twirl a gesture of cosmic poetry, assuring us that even in grand encounters, there is peace. 10. Neutron stars are incredibly dense. Among the strangest and most astonishing objects in the universe are neutron stars, remnants of massive stars that have ended their lives in brilliant supernova explosions. What remains is a city-sized sphere, typically no more than 20 kilometers in diameter, containing more mass than the Sun. Try to imagine it. A single teaspoon of neutron star material would weigh around 1 billion tons. That's the weight of an entire mountain, compacted into the volume of a sugar cube. It's a concept so staggering that it nearly defies belief. This density is the result of gravity collapsing protons and electrons into neutrons, tightly packed into a solid core. Neutron stars rotate at astonishing speeds. Some spin hundreds of times per second, emitting beams of electromagnetic radiation from their poles, like cosmic lighthouses. These rapidly spinning neutron stars are called pulsars, and they send out rhythmic signals that can be detected across vast distances. They're so reliable that they've been used by astronomers as cosmic clocks. But beyond their strange mechanics, neutron stars hold a quiet beauty. They represent endurance. They are the leftover hearts of stars that once lit the galaxy, condensed into something unimaginably compact and stable. Even in death, these stars persist, radiating, spinning, marking time. When you feel small or overwhelmed, think of the neutron star. Think of something so small yet so powerful, so compact yet still radiating. Let it be a gentle reminder that strength doesn't always look expansive. Sometimes it's dense, concentrated, quiet. You carry strength too. Even when it's hidden, even when it feels like you've collapsed under pressure, there is something in you that still shines. 11. Saturn's rings are disappearing. Saturn's rings are one of the most iconic and captivating sights in our solar system. Made primarily of ice particles with bits of rock and dust, they stretch wide around the gas giant in stunning, shimmering bands. But like all things in the universe, they are not eternal. Scientists have discovered that Saturn's rings are slowly fading, pulled toward the planet by gravity and disintegrated by the bombardment of micrometeorites and solar radiation. The process is called ring rain, and it causes the icy particles to fall into Saturn's atmosphere like a soft, celestial drizzle. At the current rate, the rings could vanish in as little as 100 million years, a short time on cosmic scales. That means humanity has emerged at a moment in time when the rings are bright and full, a brief window in which Saturn wears its crown. This knowledge brings with it a quiet sadness, but also a powerful sense of gratitude. We are here now, able to witness their beauty. In all of history and across the lifespans of planets and stars, our moment is fleeting. And yet, in this fleeting moment, we get to see Saturn's rings shine. Contemplating their eventual disappearance also reminds us that even the most majestic, awe-inspiring things are temporary. But that doesn't diminish their value. On the contrary, it makes their presence all the more meaningful. Let Saturn's rings remind you to pause and admire what is around you, to cherish beauty, even knowing it may not last, and to feel thankful for your place in the cosmos, right here, right now, at the exact moment when the universe has chosen to show you its shimmering, icy crown. 12th. Jupiter's Great Red Spot is a giant storm that's lasted centuries. One of the most iconic features in our solar system is a colossal storm swirling in Jupiter's southern hemisphere. Known as the Great Red Spot, this gigantic vortex is larger than Earth and has been churning for at least 350 years, possibly even longer. First observed through telescopes in the 1600s, it continues to rotate, ever so slowly, in Jupiter's thick atmosphere. The Great Red Spot is a high-pressure region with wind speeds reaching up to 430 kilometers per hour. From afar, it looks like a pale red or orange eye, staring endlessly into the vastness of space. Scientists believe the storm's reddish color may come from chemical reactions in Jupiter's upper atmosphere, influenced by sunlight and lightning flashes deep below the clouds. What makes this storm especially mysterious is its persistence. On Earth, storms eventually break apart due to land, friction, or a lack of energy. But Jupiter has no solid surface. just layers of gas and liquid, and a constant supply of energy from internal heat, allowing storms like the red spot to continue indefinitely. The storm has been slowly shrinking in recent decades, which may mean it's evolving or weakening. Still, it remains a powerful symbol of cosmic endurance. When we reflect on it, we're reminded that some forces in nature are so vast, so steady, and so ancient that they defy our usual sense of time. As you lie in bed tonight, let your thoughts drift to this storm, turning endlessly beneath Jupiter's golden clouds. Imagine its peaceful swirling, unaffected by the passage of centuries. And let that sense of timelessness wash over you, reassuring you that change and persistence can coexist, and that calm can be found even in the heart of a storm. 13. Voyager 1 has left the solar system. In 1977, a small spacecraft named Voyager 1 was launched from Earth with a simple mission to explore the outer planets. But over the decades, it has become so much more than that. It is now humanity's most distant messenger, having quietly slipped beyond the outer edge of our solar system into the realm of interstellar space. Voyager 1 travels at over 61,000 kilometers per hour. In 2012, it crossed the heliopause, the boundary where the solar wind meets the interstellar medium, becoming the first human-made object to leave the protective bubble of our solar system. It now sails through the void, far beyond the orbit of Pluto, with only faint starlight and cosmic radiation as its companions. On board the spacecraft is the Golden Record, a phonograph disc carrying the sounds and images of Earth, greetings in multiple languages, music from around the world, natural sounds like thunder and ocean waves, and images of human life and nature. It's a time capsule for any intelligent life that might one day find it. A soft hello from a small, blue planet. What's most moving is the silence that surrounds Voyager now. It communicates with Earth, but its signals take over 22 hours to reach us, and every day it moves farther away. Still, it keeps going, quiet, steady, loyal. Voyager 1 is a reminder that even the smallest of vessels can travel the farthest, that something built by human hands, launched with hope and curiosity, can escape the sun's embrace and wander forever. Let it soothe you. This thought of a lonely craft sailing peacefully through the stars, our quiet ambassador to the universe. 14. The moon is slowly drifting away from Earth. Each night, the moon graces our sky, its pale light a comfort and a guide. But did you know that the moon is slowly drifting away from Earth? Every year, it moves about 3.8 centimeters farther into space, a rate roughly equal to how fast your fingernails grow. This drift is caused by a gentle gravitational interaction between the Earth and the moon. As Earth rotates, it creates tidal bulges in the oceans that pull slightly ahead of the moon. These bulges exert a small gravitational pull on the moon, gradually pushing it away. At the same time, Earth's rotation is very slowly slowing down, adding a few milliseconds to our day over millions of years. Billions of years ago, the moon was much closer. In the distant past, it would have looked enormous in the sky, casting dramatic tides and lighting up the night more brightly than it does today. And billions of years from now, it will be so far away that it won't fully cover the sun during solar eclipses, ending the era of total solar eclipses forever. There's something quietly emotional about this movement. The moon has always been with us, our closest celestial companion. And yet, it is slowly leaving. Not in a hurry, not with violence, just gently, gradually, step by step. Let this be a reminder that change doesn't always have to be dramatic. It can be slow, peaceful, and even beautiful. Sometimes things move apart with grace, and in that grace, we can find acceptance and even comfort. 15. Earth is in a constant state of motion. Even as you lie still, your body relaxed and your eyes slowly drifting shut, you are in motion, constant motion. Earth spins on its axis at about 1,670 kilometers per hour at the equator, and it orbits the Sun at a blistering speed of around 107,000 kilometers per hour. Yet we don't feel it. The motion is so smooth, so consistent, that life continues as if we were perfectly still. But that's only the beginning. The entire solar system is also moving, orbiting the center of the Milky Way galaxy at approximately 828,000 kilometers per hour. And our galaxy itself is drifting through space, pulled by the gravitational embrace of other galaxies and vast unseen structures. You are on a planet circling a star, circling a galaxy, floating in the cosmic current. This relentless motion might sound dizzying, but it can also be deeply calming. Because no matter how fast we move through space, we are cradled in a rhythm older than memory. A rhythm that has guided the stars and planets for billions of years. It is gentle, it is dependable, and it surrounds us always. You don't need to worry about direction or speed. The universe is carrying you, softly and constantly, through the fabric of space. There's nothing you need to do. Just be. You are part of the grandest motion in existence, and that alone is enough. 16. A spoonful of a white dwarf star would weigh tons. White dwarfs are the remnants of stars like our Sun, stars that have exhausted their fuel and shed their outer layers, leaving behind a hot, dense core. These stellar corpses no longer undergo fusion, but they continue to glow softly for billions of years, cooling slowly over time. What's astonishing about white dwarfs is their density. A typical white dwarf packs a mass similar to the Sun into a sphere roughly the size of Earth. That means a single teaspoon of white dwarf matter would weigh several tons. This density defies everyday understanding. It's the result of gravity squeezing matter so tightly that electrons are forced into the smallest possible space. And yet, despite their extreme weight, white dwarfs are quiet. They don't explode or collapse further, at least not without help. They exist in serene silence, slowly fading, gently releasing the last of their warmth into the universe. Their existence reminds us that transformation doesn't always end in destruction. Sometimes, after a bright and brilliant life, there is a quiet stage, a phase of stillness, compact strength, and gradual fading. That stage too is beautiful. It carries a dignity of its own. So when you feel exhausted or faded, remember the white dwarf. Even in stillness, there is weight, there is meaning, there is light. 17. A galaxy cluster can span millions of light years. When we talk about the universe, we often think of stars and galaxies, but zoom out even further, and you'll find galaxy clusters, massive collections of hundreds or even thousands of galaxies bound together by gravity. The size of these clusters is staggering. Some span over 10 million light years across. Within them are vast amounts of dark matter, glowing clouds of superheated gas, and ancient galaxies moving together through space. The gravity in these clusters is so immense that it bends light itself, a phenomenon known as gravitational lensing, which allows us to see distant objects behind them. One of the most famous clusters, the Virgo cluster, is relatively close to us in cosmic terms, about 65 million light years away. Our Milky Way is on the outskirts of a supercluster that includes Virgo, called the Laniakea supercluster, which spans over 500 million light years. These structures are not static. They are in motion, slowly flowing together in cosmic rivers drawn by gravity. What does this mean for us? It means we are part of something so vast, so intricate, that it stretches beyond human comprehension. And yet, we are connected to it. Our galaxy is a small note in a symphony played over billions of years. As you lie down tonight, imagine drifting not just through your thoughts, but through clusters of galaxies, light years upon light years of motion, light, and quiet majesty. Let the enormity of it all wash over you and shrink your worries. You are floating in a cosmic current, surrounded by stars, dust, and quiet forces that have shaped the universe for eons. 18. The Sun will eventually become a white dwarf. When we think of the Sun, we picture a bright, steady companion lighting our days and nurturing life on Earth. But like all stars, the Sun is on a journey, one that will stretch billions of years into the future. And at the end of that journey, it will transform into something new and quiet, a white dwarf. Currently in the prime of its life, the Sun is a middle-aged star, steadily fusing hydrogen into helium in its core. This process gives off the light and warmth we depend on. But over the next 5 billion years, the Sun will slowly exhaust its hydrogen fuel. When that happens, it will swell into a red giant, growing so large that it may engulf Mercury, Venus, and even Earth. Eventually, the outer layers of the Sun will drift away into space, creating a glowing shell of gas called a planetary nebula. What remains at the center will be a small, dense core, a white dwarf. This ember of a once great star will quietly shine for billions more years, slowly fading into darkness. This process is not to be feared. It is natural, beautiful, and slow. It reminds us that even the brightest forces in our lives have life cycles, and endings are not necessarily violent or sudden. They can be peaceful, graceful, transformative. Let this future vision of our Sun offer you comfort. Just like stars, we too have phases, times of brightness, of expansion, of quiet retreat. All of them are part of the journey. 19. Black holes can slow down time. Black holes are among the most mysterious and powerful objects in the universe. Their gravity is so intense that nothing, not even light, can escape once it crosses the event horizon. But beyond their ability to trap matter and energy, black holes also have an incredible effect on time itself. According to Einstein's general theory of relativity, time moves slower in stronger gravitational fields. Near a black hole, where gravity is immense, time can slow to a crawl compared to regions farther away. If you were to hover near the edge of a black hole, close to its event horizon, just a few minutes could pass for you while years or even centuries pass elsewhere. This effect isn't just theoretical. It's been demonstrated in simulations and reflected in extreme astrophysical observations. It means that black holes don't just bend space, they bend time. They are cosmic time machines of a sort, capable of warping the very flow of reality. Imagine looking out from the edge of a black hole and seeing the universe speed up around you. Stars racing through their lives, galaxies spinning more quickly, whole epochs unfolding while your own clock ticks slowly. It's a surreal and humbling concept. This idea invites us to reflect on time in our own lives. It's not always uniform. Some days feel endless, others pass in a blink. But all of it is relative, shaped by our perspective, by our presence. Let the black hole teach you that slowing down is not a failure. It's a part of existence itself. 20. Cosmic background. Radiation is the echo of the Big Bang. In every direction we look, the universe is filled with a faint, uniform glow known as the cosmic microwave background radiation. It's not light from stars or galaxies, but the afterglow of creation itself, a whisper from the very birth of the cosmos. This radiation is the leftover heat from the Big Bang, stretched across the universe over billions of years as space itself expanded. Discovered in 1965, this ancient light provides one of the strongest pieces of evidence for the Big Bang theory. It comes to us from a time when the universe was just 380,000 years old, a mere infant compared to its current age of 13.8 billion years. Although the temperature of this radiation is only about 2.7 degrees above absolute zero, it fills all of space. It's like a quiet, cosmic lullaby, humming softly in the background of everything. Every time we turn on a sensitive radio receiver or space telescope, we catch a glimpse of this ancient signal, carrying the memory of the universe's beginning. There's something deeply comforting in that. The universe has a memory, a trace of where it came from. And you are part of that same story. The particles that make up your body were born in stars. But those stars came from clouds shaped by the very forces unleashed in the Big Bang. You are not separate from the universe's origin. You are a continuation of it, a gentle echo that walks, breathes, dreams. So as you close your eyes tonight, remember that you carry within you the rhythm of the beginning, and that the universe is still singing softly, even now. 21. A neutron star's magnetic field is unimaginably powerful. Among the many celestial wonders in the universe, neutron stars stand out not only for their incredible density, but also for their unfathomably strong magnetic fields. These compact remnants of supernova explosions pack more mass than the sun into a sphere just about 20 kilometers wide. But what's even more astonishing is the strength of their magnetism. Some neutron stars, called magnetars, have magnetic fields 1,000 trillion times stronger than Earth's. These magnetic fields are so intense that they can twist atoms into long, thin shapes and cause space around them to shimmer with strange quantum effects. Even from thousands of kilometers away, a magnetar's field could erase data on a credit card or disrupt the structure of matter itself. Despite this immense power, magnetars and neutron stars are peaceful in their solitude. They rotate in silence, pulsing softly as they emit beams of radiation. We detect them as rhythmic blips, pulsars, like a lighthouse guiding ships in the night. Some spin hundreds of times per second, keeping time with astonishing precision. There's a quiet comfort in knowing that such powerful forces exist in the universe, not as threats, but as steady, enduring beacons. They remind us that strength can be silent, that power doesn't have to shout to be heard, and that even in isolation, there can be beauty and rhythm. Let this idea wrap around you like a warm blanket. In the deepest reaches of space, something incredibly small, incredibly dense, and unbelievably magnetic pulses gently, alone, but never lost. 22. The coldest place in the universe is in a distant nebula. When you think of cold, you might imagine the chill of a winter night, the frost on a window pane, or the vacuum of deep space. But the coldest natural place we've found in the universe is the Boomerang Nebula, a young planetary nebula about 5,000 light-years from Earth in the constellation Centaurus. The Boomerang Nebula has been measured at just 1 degree Kelvin above absolute zero. That's negative 272 degrees Celsius, colder than the faint glow of the cosmic microwave background. This bizarre temperature is due to the way the dying central star expels gas into space, expanding so rapidly that it causes an extreme drop in temperature, much like air from an aerosol can become cold when released. This icy environment is breathtaking in more ways than one. From afar, the nebula looks like a ghostly hourglass, glowing softly against the darkness. It's a quiet reminder that even in the violence of stellar death, there can be grace. The star isn't exploding, it's letting go, in a long, slow exhale that chills the very fabric of space. There's poetry in this process. A star, once full of fire, is ending not with a bang, but with a shiver. It leaves behind not destruction, but an ethereal sculpture, a monument to change and to beauty in stillness. Let this image soothe your thoughts. Even in the coldest places in the universe, there is light. Even in endings, there is elegance. 23. The largest known star would stretch beyond Jupiter's orbit. In the grand theater of the cosmos, few characters are as humbling as Scuti, the largest known star in terms of sheer volume. Located over 9,000 light-years from Earth in the constellation Scutum, this red supergiant is a cosmic giant beyond imagining. If Scuti were placed at the center of our solar system, its surface would extend beyond the orbit of Jupiter. That means it would engulf Mercury, Venus, Earth, Mars, and potentially Jupiter itself. The scale is staggering. It's not the most massive star, that title belongs to others, but in size alone, it reigns supreme. Despite its enormity, Scuti is relatively cool in temperature, radiating a soft reddish glow. It has a quiet presence, luminous, but not scorching. Its life will end one day in a supernova, but for now, it swells and breathes gently, a sleeping giant among the stars. Stars like Scuti help us understand the full range of stellar evolution. They remind us how varied the universe is, how different one star can be from another. Our sun, while essential to us, is just a modest player in the cosmic lineup. There's something profoundly relaxing in this perspective, to know that giants like Scuti exist, serene in their distance, offers a sense of scale that makes everyday worries feel small. You are safe beneath your sun, on a small blue planet, quietly drifting through a sky full of distant giants. Let this knowledge give you comfort tonight. The universe is immense, filled with stars that dwarf comprehension, yet each one burns in peace, and so can you. 24. Rogue planets drift alone in the darkness. Not every planet orbits a star. Some wander through the galaxy completely alone, cast out from their solar systems or formed in isolation. These are rogue planets, worlds adrift in the vast darkness of space without a sun to anchor or warm them. Scientists estimate there could be billions of rogue planets in our Milky Way galaxy alone. Some are as small as Earth, others as large as Jupiter. They are cold, lonely, and nearly invisible, detectable only through the subtle gravitational effects they have on nearby objects, or when they briefly block the light of distant stars during rare alignments. Though they drift in darkness, rogue planets are not lifeless by definition. Some may retain internal heat, warmed by radioactive decay or the remnants of their formation. It's possible that beneath thick ice crusts, subsurface oceans could exist, quiet, sealed environments where exotic life might survive in peaceful isolation. These solitary worlds are a reminder that even in the darkest places there is potential. They speak of resilience, of existence without dependence on light or orbit. Like quiet travelers, they roam the galaxy unseen, unknown, unbothered. Let the image of a rogue planet comfort you. It moves without a path, yet it continues. It is alone, but it endures. There is peace in wandering and beauty in the stillness of space. 25. The universe is flat, but not in the way you think. When cosmologists say the universe is flat, they're not talking about shape the way we think of a pancake or a sheet of paper. Instead, they mean that the geometry of space on large scales follows the rules of Euclidean geometry. Parallel lines stay parallel, and the angles of a triangle add up to 180 degrees. This concept of flatness comes from observations of the cosmic microwave background radiation and measurements of the universe's total mass and energy. If the universe had more mass, it would curve inward like a sphere. With less mass, it would curve outward like a saddle. But it appears that the universe is just right, not too dense, not too sparse, flat. This discovery has enormous implications. It suggests that the universe could expand forever, slowing gradually, but never quite stopping. It also supports the theory of cosmic inflation, that in the earliest moments after the Big Bang, the universe expanded rapidly and evenly in all directions, smoothing out any large-scale curves. There's something deeply reassuring in that balance. The universe, with all its complexity and chaos, maintains a quiet, elegant symmetry, not bent or broken, but gently, perfectly flat. So as you settle in tonight, think of the cosmos not as a chaos of twists and turns, but as a vast, calm plain, stretching endlessly in every direction. A quiet, balanced expanse where every step forward leads gently and forever into the stars. 26. Some galaxies are older than the light we can see. Light takes time to travel, and the farther away an object is, the longer its light takes to reach us. So when we observe distant galaxies, we're not seeing them as they are now. We're seeing them as they were when their light began its journey to us. Thanks to powerful telescopes like Hubble and James Webb, we can look back billions of years in time. We've detected galaxies that existed just a few 100 million years after the Big Bang. These early galaxies are among the oldest we can observe, and their light has been traveling toward us for over 13 billion years. But here's the wonder. Those galaxies have continued to evolve in the time since their light began its journey. They've aged, changed shape, merged with others, or faded away. Some may no longer exist at all. We are witnessing only their earliest moments, their long-gone glow reaching us like echoes from a forgotten dream. This time, delay means that much of the universe remains hidden in its present form. We see only glimpses of what was, like snapshots frozen in ancient light. It reminds us that reality has layers. What we perceive now is only part of the full story. So let the light of ancient galaxies lull you into sleep. Their messages took eons to arrive. They have waited patiently to be seen, and now they greet you with quiet wisdom from a universe far older than memory. 27th. Quasars are the brightest objects in the universe. Deep in the hearts of distant galaxies, something extraordinary happens. A supermassive black hole, millions or even billions of times the mass of our sun, sits quietly until it begins to feast. As gas and dust spiral toward it, they heat up and ignite with unimaginable energy. The result is a quasar, an object so bright it can outshine an entire galaxy. Quasars are powered by accretion disks around black holes. The friction and gravitational energy released by the spiraling material generates intense radiation across the electromagnetic spectrum, including visible light, ultraviolet, and X-rays. From billions of light years away, we can detect these brilliant beacons. In fact, the most distant quasars we see today are also the oldest. We're witnessing their light from a time when the universe was young. Despite being located so far away, quasars are incredibly luminous. Some emit thousands of times more energy than all the stars in the Milky Way combined. Yet their light reaches us, soft and ancient, as if whispered from across the fabric of time. Quasars show us that even in the most violent, chaotic places in the universe, where gravity is strongest and matter is consumed, there can be radiant light. They remind us that beauty and brilliance often emerge from the very edge of destruction. Let that thought ease your mind. You too can shine even when things feel heavy. Light, like hope, can come from the darkest places. 28. The observable universe has a limit. When we look up at the night sky, it feels infinite. Stars stretch in every direction and space appears endless. But in truth, we can only see a fraction of the entire universe, what scientists call the observable universe. This cosmic horizon is defined by the speed of light and the age of the universe. Because light takes time to travel, and the universe is about 13.8 billion years old, the furthest we can see is roughly 46 billion light years in every direction. Beyond that, the light from distant galaxies hasn't had enough time to reach us. It's not that those galaxies don't exist. They do. They're simply beyond our reach, hidden behind a curtain of time and distance. The universe itself might be infinite, but our ability to observe it is not. This boundary isn't a wall or an edge. It's a gentle limit, a horizon that moves slowly outward as the universe ages and light from farther away finally arrives. Every day, the observable universe grows a little bit, like a flower unfurling its petals to reveal more of the garden beyond. Let this cosmic truth bring you comfort. There is more beyond what we can see. More beauty, more mystery, more light. And just because something is beyond your view now doesn't mean it will stay that way forever. 29. The James Webb Space Telescope sees the past. Launched into space in December 2021, the James Webb Space Telescope, JWST, is humanity's most powerful eye on the cosmos. Positioned far beyond the Moon, in a stable orbit called L2, JWST peers deep into the universe, not to witness the present, but to look back in time. JWST observes in the infrared spectrum, which allows it to see through cosmic dust and glimpse the light from the earliest stars and galaxies. Because light takes time to travel, the further Webb looks, the older the light it captures. Some of the images it sends back show galaxies as they existed just a few 100 million years after the Big Bang. This telescope is like a time machine. It doesn't just show us stars and planets. It reveals the story of the universe's birth and growth. Its mirrors, polished to incredible precision, reflect the faintest echoes of ancient light, allowing us to witness events that shaped everything we know. But there's more to JWST than science. There's wonder. In its golden mirrors, we see reflections of our curiosity, our desire to explore, and our longing to understand where we come from. As you drift off to sleep, imagine yourself floating beside the telescope, gazing quietly into the past. Let the idea of time unfolding backward wrap around you like a soft blanket. You are not just living in the present. You are connected to all of time, gently cradled by light that began its journey billions of years ago. 30. There are entire galaxies without stars. It's easy to think of galaxies as vast collections of stars glowing brilliantly across the night sky. And most are. But there exist galaxies that defy this expectation. Dark galaxies, almost invisible, composed primarily of gas and dark matter, with few or no stars at all. These starless or nearly starless galaxies are elusive. They don't emit light like typical galaxies do, making them difficult to detect. Often, we find them only by the way their gravity affects nearby luminous objects, or by faint traces of hydrogen gas they emit in radio frequencies. Why don't these galaxies form stars? In many cases, it's because they lack the conditions necessary for star formation. The gas may be too diffuse or too hot, or perhaps they were disrupted early in their formation, their material scattered by nearby galactic collisions or stripped away by tidal forces. Still, they exist, quietly drifting in the cosmic sea. Massive structures filled with invisible matter and the potential for stars that may never shine. They are cosmic maybes, worlds of possibility that never ignited. Their presence reminds us that not everything that exists must be visible, that quiet, unseen things can still shape the universe. Just as dark galaxies influence their surroundings through gravity, so too can your presence impact the world, even in silence. 31. Some stars travel alone at incredible speeds. In the vast calm of space, you might imagine stars slowly orbiting galaxies in elegant spirals. But not all stars follow this graceful rhythm. Some are hurled out of their galaxies entirely, flung into intergalactic space at breathtaking speeds. These are known as hypervelocity stars. These runaway stars can travel at more than 1 million miles per hour, fast enough to escape the gravitational pull of their home galaxies. They are often the result of dramatic encounters, like a close brush with a supermassive black hole, or the explosive disintegration of a binary star system. Despite their speed, hypervelocity stars are isolated and serene. They drift through space alone, far from the comforting clusters of other stars, their motion shaped by ancient cataclysms. To be a hypervelocity star is to be in motion forever, a cosmic traveler unbound. It's a life of solitude, yes, but also of freedom. These stars may never return home, but they light the path wherever they go. There is peace in their journey. a sense that even if you're cast out by chaos, you can still burn bright, still move forward, still leave a trail of light behind you. 32. The universe might be infinite. When you try to picture the universe, does your mind search for an edge, a wall, a boundary, some outer limit? But based on our current understanding, the universe might not have an edge at all. It could be infinite, stretching on forever in every direction. This doesn't mean it's filled infinitely with stars and galaxies. Beyond the observable universe, we simply don't know what lies out there. It could be more of the same, or it could be radically different. But the geometry of space, the expansion rate, and the distribution of matter all suggest one thing. We have no evidence that the universe has a boundary. An infinite universe is difficult to grasp. It defies our intuition. Yet it also offers a strange comfort, because in an infinite universe, there's room for everything, for every possibility, every story, every version of existence. It means that the patch of sky above your head, the breath you just took, the moment you are living in, these are all part of something that has no end, something timeless, something vast enough to contain every dream and every thought you've ever had. Let that thought settle over you as you drift towards sleep. You are not confined. You are not small. You are a part of something limitless, something eternal, and that makes your place in it all the more precious. 33. The solar system is surrounded by a giant bubble. Our entire solar system, planets, moons, the sun, and all, is moving through the galaxy enclosed within a vast protective bubble known as the Heliosphere. This invisible shell is created by the solar wind, a stream of charged particles constantly flowing from the sun. As this wind pushes outward, it carves a bubble in the interstellar medium, the thin gas that fills the space between stars. The heliosphere acts as a shield, helping to deflect high-energy cosmic rays that originate from outside our solar system. It gently cocoons us, like a soft cosmic cushion, guarding our home as it drifts through the galaxy. The boundary where the solar wind slows and meets the interstellar medium is called the heliopause, and beyond that lies true interstellar space. This massive, protective structure isn't static. It's shaped by the sun's activity and our motion through the galaxy. Voyager 1 and Voyager 2, the farthest human-made objects, have crossed this boundary and now send us quiet whispers from outside the bubble. Imagining this bubble slowly gliding through the galaxy is strangely comforting. We are protected. We are not adrift but embraced by physics, by nature, by the sun itself. You are safe in this floating cradle, rocked gently by the forces of the cosmos. 34. The universe has no center and no edge. It might seem logical that if the universe began with a big bang, there should be a central point from which everything exploded outward. But the reality is more subtle and far more beautiful. The universe has no center, and it has no edge. Instead, space itself is expanding everywhere all at once. Think of it like a rising loaf of raisin bread in the oven. As the dough expands, each raisin moves away from every other raisin, not from a single central point, but as a result of the dough itself growing. Every galaxy is like a raisin, and the dough is space-time. From any point in the universe, it looks like everything else is moving away. This means every observer, no matter where they are, sees themselves as being at the center of expansion. There is no absolute middle, no wall or edge to reach, just more space, stretching infinitely. This challenges the way we think about space and place, but it also brings a soothing sense of unity. No place is more central than another. No position is more important. We are all at the heart of the universe, each in our own way. Let that idea settle into you as you rest. You don't need to be anywhere else. You are already at the center of everything that matters. 35. light can be bent by gravity. In the quiet depths of space, light doesn't always travel in straight lines. It can bend, curve, and stretch, not because of obstacles, but because of gravity. This gentle warping of light is called gravitational lensing, and it's one of the most fascinating phenomena in modern astronomy. When light from a distant star or galaxy passes near a massive object like a galaxy cluster or black hole, the gravity of that object bends the path of the light, much like a lens bending a beam. To an observer on Earth, this bending can create rings, arcs, or even multiple images of the same distant galaxy. Einstein predicted this effect in his theory of general relativity, and it's now used to study some of the most distant and faint objects in the universe. Gravitational lensing acts like nature's magnifying glass, helping us see things we otherwise couldn't. It's a reminder that the universe is full of subtle interactions, that light, the fastest thing we know, can still be guided and shaped, and that the invisible hand of gravity is always at work, gently curving the fabric of space and time. Let this truth comfort you. Even light can change direction when influenced by something greater. And like that light, you too can bend gracefully, adapting to the gravity of your life without losing your brilliance. 36. There's a giant cloud of alcohol in space. Deep in the constellation Sagittarius, more than 10,000 light-years from Earth, floats a vast invisible cloud. It isn't made of water or stardust, but of alcohol. Specifically, it contains massive quantities of ethyl alcohol, the same type found in alcoholic beverages. This interstellar cloud, known as Sagittarius B2, spans a region about 1,000 times the diameter of our entire solar system. Before you imagine space bartenders serving cosmic cocktails, know that this alcohol is diluted across unimaginable distances and mixed with other complex organic molecules. It would take far more than a glass to make any difference, but still, it's there, floating, ancient, and oddly familiar. This discovery isn't just a fun fact. It's part of a growing body of evidence showing that the ingredients for life are scattered throughout the universe. Sugars, amino acids, and even precursors to DNA have been found in similar molecular clouds. Sagittarius B2 reminds us that the universe is not just rocks and radiation. It's a place where chemistry flourishes, where the building blocks of life float freely through the void. It's a cosmic kitchen, quietly mixing, waiting, and whispering of possibilities. So next time you raise a glass, think of the vast cloud in Sagittarius, a toast from one part of the universe to another. 37. Some moons have subsurface oceans. Not all water in the solar system is found on Earth. In fact, some of the most intriguing oceans may lie hidden beneath the icy crusts of distant moons. Europa, a moon of Jupiter, and Enceladus, a moon of Saturn, are both believed to harbor vast subsurface oceans beneath their frozen exteriors. Despite the distance from the Sun, these oceans are kept liquid by internal heat, generated by tidal forces and the gravitational pull of their parent planets. Scientists have observed geysers of water vapor erupting from the surface of these moons, hinting at the oceans below. These plumes suggest not just water, but potential energy sources and chemical nutrients, ingredients that on Earth support life in the darkest ocean depths. It's possible, then, that life exists elsewhere in our solar system, not on sunlit surfaces, but in the warmth of hidden oceans, shielded from radiation and temperature extremes. If life can survive in the deep oceans of Europa or Enceladus, it may be thriving there right now. These moons remind us that the most profound discoveries might be hidden beneath the surface. Just because something isn't visible doesn't mean it isn't alive, vibrant, or meaningful. 38. Galaxies can collide without stars touching. When we think of galaxies colliding, we often imagine stars crashing into each other in violent explosions. But the reality is far more elegant and peaceful. Galaxies can pass through each other and merge, all without their stars ever actually colliding. That's because galaxies are mostly empty space. Even in the densest regions, the vast distances between stars make direct collisions incredibly rare. Instead, the gravitational dance between galaxies causes stars to shift orbits, clouds of gas to collide and compress, and new stars to be born. Our own galaxy, the Milky Way, is on a slow-motion collision course with the Andromeda Galaxy. In about 4 billion years, the two will begin to merge. The sky above Earth, or whatever world exists then, will glow with ribbons of stars as the galaxies swirl together. Over time, they will settle into a new, unified structure, probably an elliptical galaxy. The process will take billions of years, yet life on planets may continue largely undisturbed. This cosmic ballet reminds us that change doesn't have to be violent. Great transformations can unfold slowly, beautifully, and without harm. Collisions can be graceful. Endings can lead to new beginnings. Let that thought soothe your mind. Even when the world shifts around you, there can be harmony in motion. 39. The sun sings a silent song. The sun is not silent. Though space itself is a vacuum where traditional sound cannot travel, the sun pulses and vibrates in rhythmic patterns, like a giant musical instrument resonating across millions of kilometers. These vibrations are caused by turbulent convection currents and magnetic waves within the sun's interior, creating pressure waves that ripple through its hot plasma. These solar oscillations produce frequencies that scientists refer to as the sun's songs. Using specialized instruments aboard spacecraft and solar observatories, astronomers can convert these vibrations into audible sound. The result is a low, resonant hum, a deep, soothing tone that rises and falls like the breath of a sleeping star. This celestial music helps scientists understand the sun's internal structure. By listening to its vibrations, they can map its layers, study its composition, and even predict solar activity. It's like using sound to explore something we can't directly touch. There's something deeply peaceful about this. Our sun, giver of life and warmth, sings a song we can't hear with our ears but can feel in the quiet pulse of its light. Its music isn't loud or urgent. It's calm, constant, reassuring. As you lie down tonight, imagine that hum, steady, ancient, and ever-present. The sound of the sun singing you to sleep, a lullaby composed by light and time. 40. Time began at the Big Bang. The idea that time has always existed is comforting, but modern cosmology tells a more curious tale. Time itself had a beginning. It started with the Big Bang, the moment the universe burst into being around 13.8 billion years ago. Before that, there was no time, no space, no before. This concept challenges our minds because we are so deeply rooted in time's flow. Everything we know has a before and an after, but the universe's beginning is different. According to general relativity and quantum theory, time and space are interwoven, and both came into existence together. Without space, there's no time. Without time, no sequence of events. This means the universe doesn't just have a start. It defines what starting means. There was no ticking clock counting down to the Big Bang. There was only the potential for something, resting in a state we cannot yet fully comprehend. Thinking about this can be surprisingly calming. It suggests that everything, every galaxy, every star, every moment, sprang from a single spark of becoming. It's a gentle reminder that all things have beginnings, even the cosmos. Tonight, as you fall asleep, remember that time itself is a gift, an unfolding ribbon that cradles your experiences, your dreams, your very breath. And like the universe, you are part of that beautiful unfolding. 41. Some stars live fast and die young. Not all stars are destined for long, quiet lives like our sun. Some stars burn with such ferocity that they live only a few million years, a blink of an eye in cosmic terms. These massive stars, many times the size of the sun, live fast and die young, ending their lives in spectacular supernova explosions. These stars fuse hydrogen at an incredible rate, shining intensely and growing rapidly. But their size is both their gift and their curse. The greater the mass, the faster they burn through their fuel. When the fuel runs out, their cores collapse under gravity, leading to either a supernova or the formation of a black hole or neutron star. Though short-lived, these stars play a vital role in the universe. Their explosions spread heavy elements, carbon, oxygen, iron, into space. These elements become the seeds of new stars, planets, and eventually, life. In their death, they make creation possible. There's something noble in that cycle. Even the shortest lives can leave behind legacies that last for billions of years. A star that lives for just a few million years can shape the destiny of galaxies. Let that idea guide you tonight. It's not always about how long something lasts. Sometimes, it's about how brightly it shines and how deeply it touches what comes after. Your presence, your light, your warmth, they matter, and they ripple far beyond what you can see. 42. The speed of light is the universe's ultimate limit. In the vast theater of the cosmos, there is one constant that underpins everything we know: the speed of light. At approximately 299,792 kilometers per second, it's the fastest anything can travel through space. This speed sets a boundary, not just for movement, but for information, causality, and even time. Nothing with mass can reach the speed of light. As an object accelerates closer to light speed, its mass effectively increases, requiring more and more energy to push it faster. Eventually, it would take infinite energy to reach light speed, an impossibility with current physics. Only massless particles like photons, the carriers of light, travel at this sacred speed. This limit is not a flaw, it's a feature. It gives the universe its structure. It means that when we look into the sky, we're looking into the past. It places a graceful delay between events, allowing for order, sequence, and rhythm. The light from stars takes years, centuries, even eons to reach us. The further we look, the older the story we see. As you rest tonight, let this constant remind you of stability. No matter how chaotic things may feel, the speed of light is always the same. It quietly shapes the cosmos, painting the night sky with ancient glimmers like lullabies from a time long gone. 43rd, cosmic dust connects everything. We often imagine space as empty, but between the stars and planets drifts a quiet haze of cosmic dust. These tiny grains, made of carbon, silicates, and ice, float gently through the galaxy, born in the atmospheres of dying stars and released during supernovae. Though small, cosmic dust is vital. It helps cool gas clouds so they can collapse and form new stars. It gathers in disks around young stars, seeding the birth of planets. It carries organic molecules across space, sprinkling the building blocks of life wherever it goes. And here on Earth, you've breathed in cosmic dust. It falls softly from the sky, mixed with meteoric debris and particles older than our planet. In every breath, in every corner of your skin, in the soil beneath your feet, the universe leaves a trace. This invisible presence connects everything. You are linked to stars that lived and died billions of years ago, to galaxies too faint to see. The dust of the cosmos is not out there. It's here, within you, around you, always. Let that connection ease your thoughts. You are never separate from the universe. You carry it with you, gently and eternally. 44. Some black holes can power galaxies. Black holes are often seen as destroyers, dark vacuums that consume everything. But at the centers of many galaxies, including our own, supermassive black holes do more than devour. They shape, they energize, they illuminate. These cosmic titans, with masses millions or billions of times that of the Sun, can create spectacular displays of energy when they feed. As matter spirals into the black hole, it forms an accretion disk, superheated and glowing with radiation. The spinning disk generates magnetic fields, and jets of charged particles can be launched from the poles, blasting across thousands of light years. This energy output can rival or even surpass the combined light of all the stars in a galaxy. Quasars, active galactic nuclei, and radio galaxies are powered by these feeding black holes. They act as galactic engines, influencing star formation, gas movement, and the very evolution of the host galaxy. So while black holes may consume, they also create. They are not just endings, they are catalysts. They show us that immense gravity can give rise to immense beauty. Let this paradox cradle your thoughts. Even in your darkest moments, there may be power. Even in collapse, there can be radiance. The universe teaches us that creation and destruction are not opposites, but partners in the dance of existence. 45. Supernovae are the universe's most beautiful farewells. When a massive star reaches the end of its life, it doesn't fade quietly. It explodes in a final, breathtaking blaze called a supernova. In that brief, radiant moment, the star outshines entire galaxies. For a few weeks, its light can travel across millions of light years, dazzling the universe with its brilliant farewell. Supernovae are more than celestial fireworks. They are essential to life. In those explosive seconds, elements like gold, silver, and uranium are forged. These heavy atoms are flung into space, enriching the interstellar medium and seeding the formation of new stars, planets, and eventually, life itself. Every atom of calcium in your bones, every bit of iron in your blood, was once created in a supernova. So when you gaze at the stars, you're looking into the past, into the ashes and dreams of ancient suns that lived and died so you could be. There's a gentle, poignant lesson here. Even in ending, there is giving. Even in destruction, there is creation. The universe's greatest goodbyes are also its greatest acts of generosity. So as you lie in the quiet dark, imagine the last heartbeat of a distant star, bursting into color and light, a farewell turned legacy, echoing gently across time. 46. Gravity holds the universe together. You can't see it, you can't hear it. Yet gravity is the invisible thread that weaves the cosmos together. It draws apples to Earth and planets to stars. It shapes galaxies and bends light. Without gravity, nothing would have form. Everything would drift apart. Gravity is the weakest of the four fundamental forces, but its reach is infinite. It governs the motion of celestial bodies, binds solar systems, and creates the orbits of moons and planets. It anchors us to Earth while tethering stars into galaxies. This quiet force works not through noise or strength, but through constant presence. It never rests, never turns off. And it's the same everywhere. The gravity that keeps your feet on the ground is the same force that sculpts the paths of galaxies billions of light years away. In a universe that often feels uncertain, gravity is the quiet promise of connection. It says, "You belong here. You are held. You are part of a grand, invisible pattern. Let that reassurance cradle you tonight. You are not floating alone. You are gently anchored to the universe." 47. The universe is expanding faster over time. For a long time, scientists believed that gravity would gradually slow the universe's expansion. But in the late 1990s, something unexpected was discovered. The universe is not just expanding, it's expanding faster and faster. This accelerating expansion is driven by a mysterious force known as dark energy. Though we don't yet understand what it is, dark energy appears to make up about 70% of the universe. It counteracts gravity, pushing galaxies apart with increasing speed. Imagine the universe as a loaf of raisin bread baking in the oven. As it rises, the raisins, galaxies, move away from each other. But now imagine that the dough begins to stretch faster and faster, pulling the raisins apart with increasing urgency. That's our universe. This means the most distant galaxies will someday vanish from view, their light stretched beyond detection. But even as things drift farther apart, they leave behind trails of light, like gentle waves on a cosmic shore. Let that expanding vastness calm you. You are part of something that grows not in haste, but in wonder. The universe is not rushing away. It's unfolding like a quiet breath, expanding gently through time and space. 48th. Earth's magnetic field shields us from solar winds. Invisible and often unnoticed, Earth's magnetic field surrounds our planet like a gentle guardian. Generated by the motion of molten iron deep in the Earth's outer core, this magnetic shield protects us from the constant stream of charged particles known as solar wind, high-energy matter blown out from the sun. Without this magnetic field, these particles would strip away our atmosphere over time, exposing the surface to harsh radiation and making life as we know it impossible. Instead, Earth's magnetic field deflects the solar wind, funneling it harmlessly around the planet and occasionally painting the sky with the auroras, soft, glowing curtains of green, pink, and violet light near the poles. This shield is not static. It wobbles, shifts, and even reverses polarity over geological time. Yet it continues to wrap us in safety, like a planetary lullaby humming through the core of the Earth. It is one of nature's quiet miracles. Powerful, persistent, and profoundly protective. So tonight, as you sleep, know that this silent field surrounds you, an invisible hand shielding you from harm, whispering that you are safe beneath the sky. 49. Every atom in your body has traveled across the cosmos. You are not just living in the universe, you are of it. Every atom that makes up your body has traveled a journey of unimaginable distance and time. The hydrogen in your cells was born in the Big Bang. The carbon in your DNA was forged in ancient stars. The calcium in your bones, the iron in your blood, all of it came from cosmic forges scattered across the galaxy. These atoms passed through nebulae, comets, oceans, and the breath of animals. They have been stardust, sunlight, soil, and rain. Now they are you. It is one of the most gentle and humbling truths that you are made of ancient matter that has danced through the cosmos. When you speak, when you sleep, when you dream, the universe speaks, sleeps, and dreams with you. You are not separate. You are not small. You are the universe, briefly taking human form. Let that thought cradle you tonight as you drift to sleep wrapped in 1,000 million years of history. 50. The universe will eventually fade into darkness. Far, far into the future, trillions of years from now, the universe will grow dark. Stars will burn out. Galaxies will dim. The energy that fuels life, motion, and light will be spent. This is the era known as the heat death, or the big freeze, when the universe reaches maximum entropy and change comes to a still. But this ending is not violent. It is quiet, peaceful, a gentle unwinding of cosmic activity. Black holes will slowly evaporate. Atoms will drift apart. Time will stretch longer than we can comprehend, and the universe will fall into a tranquil silence. And while this might sound sad, it is also a testament to endurance. The universe will have lasted beyond stars, beyond thought, beyond memory. A long, slow exhale after a vibrant, luminous life. Let this be a comfort. All things rise and fall. All things shine and fade. But in the grand sweep of time, everything plays its part, beautiful, complete, and at peace. As you rest, imagine the universe dimming like a candle in the night. Not gone, but complete. Not empty, but still. And in that stillness, find your own peace, knowing that you too are part of the cosmic story that echoes forever. '51. The largest structure in the universe is a giant group of galaxies. Far beyond the reach of most telescopes, hidden in the distant fabric of the cosmos, lies something so immense it challenges our very sense of scale: the Hercules Corona Borealis Great Wall. This colossal structure is not a single object, but a clustering of galaxies and galactic clusters spanning an estimated 10 billion light-years across. Discovered in 2013, this structure is so vast that light itself, the fastest thing we know, would take more than 10 billion years to cross from one side to the other. That's nearly 3/4 the age of the universe itself. It defies our expectations of what should be possible based on how matter is thought to be distributed on the largest scales. This Great Wall isn't a wall in the ordinary sense. It's a name we give to a gravitationally connected structure, made of hundreds of thousands of galaxies, bound together in a grand filament of space. These galaxies form a tapestry of star systems, black holes, gas clouds, and dark matter, all moving together slowly in the grand dance of cosmic expansion. When we gaze into the sky, we see pinpoints of light, but zoom out, far, far out, and you begin to see the universe isn't empty. It's woven with these threads of galaxies, punctuated by voids and shaped by gravity over billions of years. Let the thought of the Great Wall soothe you. You are lying quietly on a tiny planet within a solar system, inside a galaxy, surrounded by a universe that stretches across unimaginable distances. And yet, you're connected to it all. Just one heartbeat in the great rhythm of something vast, slow, and beautifully complete. 52. Some stars are so old, they were born before the Milky Way formed. Long before the swirling arms of the Milky Way coiled into the familiar spiral we call home, stars were already being born. Some of them, incredibly, are still shining today. These ancient stars are like cosmic time travelers, windows into a universe that was just beginning to take shape. One of the most famous of these stars is HD 140283, often referred to as the Methuselah star. Estimated to be about 14.5 billion years old, it appears older than the universe itself, a paradox that puzzled scientists for years. More recent measurements have adjusted the age to closer to 13.7 billion years, but it remains among the oldest known stars, formed just a few 100 million years after the Big Bang. These old stars are different. They are made mostly of hydrogen and helium, with very little of the heavier elements like iron or carbon. That's because those heavier elements hadn't been formed yet. Those would come later, forged in the fiery cores of stars and scattered across space by supernovae. When you look up at the night sky, you're seeing many stars that are relatively young. But hidden among them are these ancient ones, dim, quiet, patient. They've watched galaxies form, collide, and evolve. They've survived through cosmic turbulence and the quiet drift of time. Imagine their glow as a whisper from the beginning of everything. Let the knowledge of their endurance bring you peace. These stars have burned gently for eons, and their light now mingles with our own. As you rest, know that some lights shine not in brilliance but in longevity, and there is comfort in their steady presence. 53rd. Mars has the tallest mountain in the solar system. On the dusty, ruddy plains of Mars rises a mountain so large it dwarfs anything Earth has ever known. Olympus Mons stands as the tallest volcano and the tallest planetary mountain in the entire solar system, reaching an awe-inspiring 22 kilometers high. That's nearly 3 times the height of Mount Everest. But what's more astonishing is not just its height, but its width. Olympus Mons stretches over 600 kilometers across, large enough to cover the entire state of Arizona or a country like France. Its slopes are so gentle, you could stand at the base and not even see the summit due to the curvature of the planet. This immense size is possible because of Mars's lower gravity, lack of tectonic plate movement, and a calm volcanic history. Unlike Earth, where tectonic plates move beneath volcanic hotspots, Mars's crust remains still. That means lava can accumulate in one spot over millions of years, slowly building an enormous shield volcano like Olympus Mons. Today, the volcano is likely dormant, but it stands as a monumental reminder of Mars' fiery past and geological power. Seen from orbit, it appears like a great scar on the Martian surface, wide, immense, and strangely serene. Let your mind wander there now. Imagine standing on that vast frozen slope, the sky a pale pink above you, the horizon stretching endlessly in every direction. There's silence, stillness, and the quiet strength of a mountain that has endured for hundreds of millions of years. Sometimes the grandest things rise slowly, quietly, and remain, not because they burned the brightest, but because they stood the longest. Let Olympus Mons remind you that endurance itself can be a kind of peace. 54. A year on Mercury is shorter than its day. Mercury, the closest planet to the Sun, is a world of extremes. Scorched by solar radiation and lacking a real atmosphere to regulate temperature, it experiences some of the most dramatic changes in the solar system. But one of its most fascinating features is hidden not in its surface, but in its relationship with time. On Mercury, a single day, from one sunrise to the next, lasts about 176 Earth days. Yet it completes one full orbit around the Sun in just 88 Earth days. That means Mercury's year is actually shorter than its day. This unusual phenomenon occurs because Mercury is caught in a gravitational dance called a 3-to-2 spin-orbit resonance. It rotates 3 times on its axis for every 2 orbits it completes around the Sun. As a result, its surface endures long stretches of burning sunlight followed by equally long, freezing darkness. The side facing the Sun heats to over 430 degrees Celsius, 800 degrees Fahrenheit, while the night side can plummet to minus 180 degrees Celsius, minus 290 degrees Fahrenheit. Imagine standing on Mercury's surface. The Sun would rise incredibly slowly, crawl across the sky for weeks, and set just as gradually. The passage of time would feel stretched, like a dream where everything moves in slow motion. Let this thought lull you. Time doesn't flow the same everywhere. Planets have their own rhythms, their own dances with gravity and light. On Mercury, time slows down, spins around, and weaves something entirely different. And yet, the planet continues its steady journey, quiet, ancient, and timeless in its own way. 55. Some moons have atmospheres and weather. Moons are often thought of as barren, lifeless rocks orbiting planets, but in the outer reaches of the solar system, there are moons that defy that expectation. Worlds with clouds, rain, rivers, and winds. One of the most fascinating is Titan, the largest moon of Saturn. Titan is the only moon in the solar system with a thick atmosphere. Composed mostly of nitrogen, its atmosphere is denser than Earth's, with layers of orange haze that block most visible light. Beneath this cloud cover, a strange and beautiful world exists, one shaped not by water, but by liquid methane and ethane. On Titan, it rains methane. Rivers of this hydrocarbon carve channels into the landscape. Vast lakes and seas glisten at the poles, filled with chemicals that on Earth would evaporate instantly. The surface temperature hovers around -179 degrees Celsius, -290 degrees Fahrenheit, far too cold for water-based life. But in this deep freeze, an alien weather system thrives. Winds whip through the upper atmosphere, creating sand dunes that stretch for hundreds of kilometers. Clouds form, drift, and dissolve, casting shadows on alien shores. It's a world both familiar and foreign, like Earth viewed through a cosmic funhouse mirror. As you relax, let Titan drift into your imagination. Picture those golden skies, the ripple of methane rain on a distant sea, and the hush of wind blowing across icy plains. Even far from Earth, weather sings its quiet lullaby, and in the cold and the dark, another kind of beauty stirs. 56. There's a planet made of diamond. Floating in the constellation of Cancer, about 40 light-years from Earth, is a world unlike any in our solar system. This planet, called 55 Cancri E, is a super-Earth, twice as large as our planet and far more massive. But what sets it apart is what scientists believe lies beneath its surface. An interior rich in carbon, compressed so tightly that it may be made of crystalline diamond. 55 Cancri E orbits extremely close to its host star, so close that a year there lasts only 18 hours. Its surface is thought to be a scorching inferno, with temperatures high enough to melt metal. One side always faces the star, locked in perpetual daylight, while the other remains in eternal darkness. Because of its high carbon content and intense pressure, astronomers speculate that vast portions of the planet's core could be diamond. Imagine a planet where the very crust might sparkle, where mountain ranges glisten like gemstones in the heat. Of course, it wouldn't be hospitable. The heat alone would vaporize anything we know. But in the harshness of space, such strange wonders can exist, planets that defy logic and glitter with silent majesty. Let your thoughts wander to that radiant world, a diamond floating in the dark, unreachable and unspoiled, turning silently in the light of a distant star. Not all beauty is meant to be touched. Some exists only to shine. 57. There are planets that orbit two suns. High above us, in a galaxy filled with billions of stars, there exist planetary systems unlike anything we see in our own backyard. Some of these planets orbit not one, but two stars, forever caught in a gravitational waltz between twin suns. These are circumbinary planets, and they are as mesmerizing as they are rare. One of the most famous examples is Kepler 16b. Discovered in 2011, this Saturn-sized planet orbits around two stars in perfect synchrony. From its surface, if you could stand there, you would witness a sky with dual sunsets, two glowing stars slowly dipping below the horizon, painting the atmosphere in hues unknown to Earth. Unlike fictional worlds like Tatooine from Star Wars, these planets are very real. The dual gravitational forces result in complex orbits and unusual seasons. Some circumbinary planets may experience intense fluctuations in temperature and daylight, while others settle into stable paths with rhythms of their own. The discovery of these planets changed our understanding of what's possible. It told us that planetary systems can form and thrive in environments we once thought too chaotic. It stretched the imagination and showed us how diverse the universe truly is. Let this image ease your mind. A world bathed in twin sunlight, two warm glows sharing the sky, shadows cast in opposite directions. A place where the laws of nature dance more freely. Sometimes the strangest configurations hold the most harmony. 58. There's a planet made mostly of diamond. In a star system 40 light-years from Earth, in the constellation of Cancer, orbits a planet that glimmers in our collective imagination. Its name is 55 Cancri E, and it may be one of the most dazzling places in the universe. A planet with a carbon-rich interior, possibly made in large part of crystalline diamond. Twice the size of Earth and 8 times as massive, 55 Cancri E orbits its host star so closely that a single year there lasts just 18 hours. One side is permanently scorched by the star's heat, reaching temperatures over 2,000 degrees Celsius, while the other side exists in shadowy darkness. But beneath that burning exterior lies a secret, a composition believed to be rich in carbon and silicon. Under extreme pressure and heat, much of that carbon may be compressed into diamond. If true, the planet's interior could be a glittering fortress of crystal, reflecting starlight in ways we can only dream of. No spacecraft has visited it. No probe has confirmed its luster. But the possibility alone is enough to ignite wonder. A planet that formed from the same cosmic ingredients as us, but emerged with a sparkle etched into its core. As you rest, picture this world floating silently through space, a diamond giant wrapped in fire and shadow. A reminder that even in the most unlikely places, the universe creates treasures. 59. Our solar system is moving through the galaxy at over 500,000 miles per hour. As you sit still, breathing gently, it might feel like the world is at rest. But in truth, you are soaring, traveling at over 828,000 kilometers per hour, more than 500,000 miles per hour, through the galaxy aboard our solar system. The Sun, along with all its planets and moons, orbits the center of the Milky Way in a vast cosmic loop. It takes about 225 million years to complete a single galactic year. We are halfway through one such journey now, racing along a curved path through interstellar space. This motion is imperceptible to us. There is no wind in your hair, no lurch in your step. Gravity holds everything in place. The Earth still turns, the moon still rises. But beyond all of that, our entire solar system is in motion, part of a grand celestial tide flowing around the galactic core. And we are not alone in this journey. Billions of stars move with us, caught in the spiral arms of the Milky Way, like glowing lanterns drifting down a river of starlight. Let this realization bring comfort. Even when you feel stuck, you are moving. You are riding a wave of cosmic motion that began before you were born and will continue long after. You are never still. You are part of the dance of the stars. 60. The moon smells like gunpowder. When Apollo astronauts returned to their lunar modules after walking on the moon, they carried more than moon rocks on their boots and suits. They carried the scent of the moon itself. As they removed their helmets, a strange smell lingered in the cabin. It wasn't the scent of vacuum or metal. It was something unexpected: gunpowder. The astronauts described lunar dust as dry, clingy, and fine like talcum powder, but with a sharp, acrid odor. It smelled burned, yet metallic, a scent none of them had experienced on Earth. Scientists believe this smell results from the dust's highly reactive nature after exposure to solar radiation and the vacuum of space. On Earth, our atmosphere quickly alters the properties of material, but on the moon, there's no air, no water, no wind. Lunar dust is untouched, jagged, and ancient. When astronauts brought it inside the module, it reacted instantly with the air, releasing its unique aroma. Though we can't truly smell space itself, moments like this offer an almost poetic sensory connection to another world. A dusty scent clinging to a boot becomes the first olfactory signature of another celestial body. As you drift off to sleep, imagine a footprint pressed into soft gray dust beneath a black sky. A scent rising quietly from the surface, alien, but strangely familiar. Even on the moon, there are traces that touch our senses, bridging the gap between here and there. 61. Stars can get so cold, they emit no light. When we think of stars, we imagine heat, brilliance, and radiance. But not all stars burn bright. Some fail to ignite fully, never reaching the core temperatures needed to fuse hydrogen into helium. These are brown dwarfs, often called failed stars, and some of them are so cold, they barely glow at all. Brown dwarfs form like stars, condensing from collapsing clouds of gas and dust, but they lack the mass to trigger sustained fusion. As a result, they cool quickly over time, fading into objects that barely emit infrared radiation. Some brown dwarfs are cooler than a human body, with surface temperatures lower than 100 degrees Fahrenheit, 38 degrees Celsius. They drift through space in silence, dim, dark, and nearly invisible. Most can't be seen with optical telescopes. Only in recent years, with advanced infrared observatories like WISE and Spitzer, have we begun to detect them in greater numbers. It's believed that brown dwarfs may outnumber visible stars in the galaxy. These cold stars are reminders that not everything that exists has to shine. Some things, some beings, some places move quietly through the cosmos, unseen, but no less real. So rest easy knowing this. Even the coldest stars still belong. They are part of the galactic symphony, humming in a lower key. Not every star must blaze to matter. 62. The universe may be teeming with rogue black holes. When we think of black holes, we often imagine them lurking at the centers of galaxies, anchoring the stars with immense gravity. But recent research suggests something stranger. There may be countless black holes wandering the galaxy alone. These are rogue black holes, and they drift silently through the darkness, invisible and immense. A rogue black hole can be formed in the aftermath of a violent supernova or ejected from galactic centers after gravitational interactions. With no light to reveal them, they move undetected unless they pass close enough to distort the path of nearby stars or bend the light from more distant objects. A phenomenon known as gravitational lensing. Some may be small, the remnants of collapsed stars. Others might be giants, roaming the void after being cast out of galactic collisions. It's estimated that hundreds of millions of these rogue black holes could exist in our galaxy alone. They do not threaten us. The cosmos is vast, and encounters are rare. But their presence reminds us that even in the great silence of space, hidden travelers move quietly, shaping the universe in ways we can barely perceive. Let your mind wander to one of these unseen wanderers. A black hole drifting slowly and silently between the stars, cloaked in shadow. Not out of malice, but simply because that is its nature. Even the darkest things have their place in the cosmic story. And sometimes they pass by unnoticed, like dreams we never quite remember. 63. Time passes faster on the moon than on Earth. It may seem like time is universal, ticking away at the same rhythm no matter where you go. But thanks to Einstein's theory of general relativity, we know that time flows differently depending on gravity. The stronger the gravitational field, the slower time passes. And because Earth is more massive than the moon, time actually moves slightly faster on the moon. This difference is incredibly small, measured in tiny fractions of a second, but it's very real. A clock on the moon would tick just a bit faster than one on Earth. If an astronaut lived on the moon for a year and then returned, they would have aged ever so slightly more than someone who remained on Earth. This phenomenon is part of what scientists call time dilation. We've observed it with GPS satellites, which must account for both their speed and their distance from Earth's surface to stay accurate. Even though we don't feel these differences in daily life, they subtly shape our experience of time across the universe. Imagine standing in a lunar crater under a star-filled sky, knowing that each second you experience is just a little longer than those felt by friends back home. The moon's silence, its low gravity, and now even its rhythm of time is different, calmer, lighter, a reminder that time itself bends gently with the shape of the cosmos. 64. Galaxies can be shaped like rings, tadpoles, or jellyfish. When we think of galaxies, we often picture elegant spirals like the Milky Way or massive elliptical blobs. But the universe is filled with galaxies of many shapes, some of them wildly different and unexpectedly beautiful. Some look like rings, others like tadpoles, and a few resemble floating jellyfish drifting in the cosmic sea. Ring galaxies form when one galaxy punches through the heart of another, sending out waves of star formation that ripple outward in a perfect circle. The Cartwheel Galaxy is a stunning example, glowing like a cosmic eye in the dark. Tadpole galaxies are named for their long, luminous tails that trail behind a compact, bright head. These form during galactic collisions or close encounters, where gravitational forces stretch the stars and gas into elegant streams. Jellyfish galaxies trail tendrils of glowing gas behind them, stripped away as they plunge through dense galactic clusters. These tails stretch out like cosmic bioluminescence, painting the void with motion and color. Each of these shapes tells a story of interaction, transformation, and movement through the cosmos. They remind us that the universe is dynamic, playful, and expressive. Not all galaxies fit into neat categories. Some break the mold, swirling into art. Let their strange beauty lull you. Out there, in the quiet dark, galaxies drift like living creatures, fluid, unique, and endlessly fascinating. 65. Some black holes roam intergalactic space. Most black holes are found nestled in galaxies, anchoring them with invisible gravity. But some wander alone, drifting through the vast stretches of intergalactic space, rogue black holes, untethered from stars and spiral arms. These cosmic nomads are thought to be the remnants of galactic collisions or powerful gravitational slingshots. When galaxies merge or stars are torn apart, black holes can be flung away with incredible force. Once separated from their galactic homes, they drift in silence, undetectable unless they interact with matter or bend light from distant sources. One such rogue black hole was recently detected by its gravitational lensing, bending the light of a distant star and revealing its presence by how it altered the star's brightness over time. This was the first direct evidence of a free-floating black hole, a ghost moving between galaxies. Though they pose no danger to us, their existence is humbling. The universe is not just filled with galaxies and stars, but also with these dark wanderers, reminders that even the most massive, powerful objects can find themselves adrift. Let your thoughts follow one of these silent travelers, alone but not lost, moving slowly through space untouched and unseen. Not a monster, but a mystery. Not destruction, but possibility. Even in darkness, there is grace. 66. Cosmic rays are constantly passing through you. Right now, as you read these words, tiny particles from deep space are zipping through your body, moving at nearly the speed of light. These are cosmic rays, high-energy particles that originate from sources as dramatic as supernova, black holes, and even the remnants of the Big Bang. Most of them are protons or atomic nuclei stripped of their electrons. They travel across the galaxy, sometimes for millions of years, before finally reaching Earth. Our atmosphere protects us from their full intensity, but a small number still make it to the ground, and even into you. Each second, thousands of cosmic rays pass through your body. You don't feel them, you don't hear them, but they're there, gentle whispers from the universe's most violent events. In higher altitudes or on airplanes, the rate increases. Astronauts aboard the International Space Station experience a much higher dosage, and scientists study these particles to understand both their origins and their effects on living tissue. Let this truth be a quiet comfort. You are not alone in your stillness. Even in the calm of night, the universe continues its gentle interactions. Tiny messengers from distant galaxies pass through you with every breath, like stardust in motion, tracing the invisible threads between here and the stars. 67. Saturn could float in water. Saturn, the ringed giant of our solar system, is a planet of grace and mystery. Though it appears massive and powerful, it hides a surprising secret. It is mostly made of gas and is so light it would float in a bathtub of sufficient size. Its low density, just 0.687 grams per cubic centimeter, is less than that of water. That means, in theory, if you could place Saturn in a vast enough ocean, it would bob gently on the surface like a colossal balloon. Of course, such a scenario is impossible, but the image is wonderfully serene. Beneath its golden atmosphere lies a core surrounded by layers of hydrogen and helium. Its outer clouds, shaped into bands by strong winds, swirl around a planet with no solid surface. Even its iconic rings are made mostly of ice, shimmering particles suspended in orbit. Saturn reminds us that size doesn't always mean heaviness, that beauty can be weightless, and that strength can come wrapped in softness. As you settle in for rest, picture Saturn gently floating, its rings glinting in the starlight, moving not with force, but with elegance. 68. Some stars are born alone in the dark. In the crowded arms of galaxies, stars are often born in clusters, formed from collapsing clouds of gas where hundreds or even thousands ignite together. But not every star joins the crowd. Some stars are born in isolation, in quiet corners of space, far from their kin. These solitary stars form in dark nebulae, dense pockets of interstellar gas that quietly collapse under their own gravity. No bursts of nearby supernovae, no glittering star nursery around them. Just silence, darkness, and the slow creation of light. Though less common, these lone stars shine just as brightly. They drift through space alone, not as outcasts, but as unique voices in the cosmic chorus. They remind us that solitude isn't emptiness, it's clarity, it's strength. Imagine one such star, glowing quietly in a field of darkness, a soft point of warmth surrounded by infinite night, not seeking attention, not craving a crowd, just shining because that is what it was born to do. Let that image carry you into sleep. Even in the dark, you can shine. Even alone, your light matters. 69. Some exoplanets may be covered in shimmering glass rain. In a distant solar system, over 60 light-years away, circles a planet both mesmerizing and extreme. HD 189733b is a gas giant larger than Jupiter, and it's famous for something almost unthinkable. Its skies may rain molten glass sideways in winds that whip at 5,400 miles per hour. The planet's deep blue color, once thought to resemble Earth's oceans, is actually due to silicate particles in its atmosphere, tiny glass-like grains suspended in high clouds. These particles scatter blue light, creating the illusion of a tranquil world. But the reality is far more turbulent. Temperatures on HD 189733b soar above 1,700 degrees Fahrenheit. The winds circle the planet faster than the speed of sound. And within those clouds, the glass grains condense and fall, slicing through the atmosphere in a violent horizontal storm. It is a world of contradiction, breathtaking beauty hiding a deadly environment. A place where rain sparkles like crystal, but shreds like shrapnel. Let your imagination drift there, not to the chaos, but to the vision. A sapphire blue sky swirling with glittering particles, a storm of shimmering glass. The universe paints strange and wonderful things, even in its harshest corners. Beauty, like peace, often lies in how we choose to look. 70. The universe has a temperature, and it's getting colder. Even the vast, empty stretches between galaxies aren't truly empty. They're filled with faint radiation, relic light from the Big Bang, spread across the cosmos like an ancient whisper. This glow, called the cosmic microwave background, tells us that the universe still holds a measurable temperature. Today, that temperature is just 2.7 Kelvin, only a few degrees above absolute zero. It's so cold, so diffuse, that we never feel it. But it's there. A subtle, ever-present reminder of the universe's fiery origin. And it's getting colder. As the universe expands, that relic heat spreads thinner and thinner. Over the coming trillions of years, the cosmic temperature will continue to fall. Eventually, the universe may reach a point of ultimate stillness, a deep freeze called the heat death, where all motion ceases and time itself seems to slow. But even now, in its coolness, the universe cradles us. That ancient warmth, though faint, connects every atom, every star, every thought. Let this thought comfort you. The universe may grow colder, but in its vastness, you are part of its warmth, born from fire, traveling through peace, returning to stillness. 71. Some neutron stars spin over 700 times per second. Deep within the remnants of colossal supernova explosions, neutron stars are born. These dense objects, just a few miles across, contain more mass than our sun. But what makes some neutron stars truly extraordinary is their spin. Some of them rotate hundreds of times each second. These are known as millisecond pulsars. With magnetic fields far stronger than anything on Earth, they emit beams of radiation from their poles. As they spin, these beams sweep across space like lighthouse beams. When pointed toward Earth, we detect them as precise, repeating pulses. The fastest known pulsar, PSRJ 1748-2446 AD, spins an astonishing 716 times per second. That means its surface moves at a significant fraction of the speed of light. Despite this unimaginable speed, it remains stable, a cosmic metronome, ticking perfectly with each rotation. These spinning stars are remnants of past violence, formed in collapse, but finding balance in motion. Their pulses help scientists study gravity, time, and even the possibility of detecting gravitational waves. As you close your eyes tonight, imagine that rhythmic beat echoing in the distance, the silent tick of a neutron star turning endlessly, keeping time for the universe. It is a reminder that even in the aftermath of destruction, something precise and beautiful can endure. 72. There are more molecules in a glass of water than stars in the universe. The universe is vast, with its hundreds of billions of galaxies and countless stars. But even that cosmic scale is dwarfed by the unfathomable number of molecules in something as small and familiar as a glass of water. If you were to count every star in the known universe, estimated to be about 10 to the power of 21, you'd still fall far short of the number of water molecules in a single 250 milliliter glass. That glass contains roughly molecules of H2O. In other words, more than 10 times as many molecules as there are stars. Each of these molecules is made of 2 hydrogen atoms and 1 oxygen atom, bonded tightly, vibrating gently, interacting constantly. They're the same kinds of molecules that shaped oceans, formed clouds, and passed through ancient rivers and living beings. This comparison gives perspective. Even in the smallest, most ordinary things, the universe is immense. Complexity doesn't require size. It thrives even in the most humble drop. So as you take a sip of water or listen to its soft rhythm, remember, you are holding the infinite in miniature. The very scale of the universe ripples through every glass, every breath, every moment. 73. The night sky is disappearing due to light pollution. For thousands of years, the night sky was humanity's window into the cosmos. Every culture gazed upward, seeing stories in constellations, calendars in the stars, and mystery in the space between. But today, most people on Earth can no longer see the Milky Way with the naked eye. This fading isn't from clouds or cosmic shifts. It's from us. Artificial light from cities, streets, and homes scatters into the atmosphere, washing out the stars. This phenomenon is called light pollution, and it's growing rapidly. In some urban centers, only the brightest stars are visible. The rest vanish behind a veil of orange glow. Astronomers now travel to remote places just to glimpse what once was common, the quiet fullness of a star-filled sky. But this isn't just about beauty. The disappearing sky disconnects us from the rhythm of nature, from perspective, from wonder. It dims our link to the universe, replacing it with flickers that fade by morning. Still, awareness is growing. Dark sky preserves and citywide initiatives offer hope. Shields on streetlights, lower wattages, and mindful lighting choices can all help return the stars to view. Let this thought guide your rest tonight. The stars are still there, patient and shining. And with care, we can bring them back into sight, not just for ourselves, but for all the dreamers yet to look up. 74. Light from the sun takes over. 8 minutes to reach Earth. The light that warms your face on a sunny day was born in the heart of the sun, millions of years ago. Deep within its core, hydrogen atoms fused into helium, releasing energy in the form of photons. These photons bounce, scatter, and zigzag through the dense interior for thousands, perhaps millions, of years before finally escaping into space. But once that journey ends, and the light bursts from the surface of the sun, its final sprint is swift. Traveling at nearly 300,000 kilometers per second, sunlight takes just over 8 minutes to reach Earth. That means when you look at the sun, never directly of course, you're seeing it as it was over 8 minutes ago. This delay exists not only for the sun, but for everything you see in the sky. The moon appears as it was a little over a second ago. The nearest stars show us light that left decades past. And galaxies? Their glow may be millions or even billions of years old. This simple truth gives our sky a poetic quality. It is not just a canopy of light, but a canvas of memories. Every photon carries a message from the past. So as you rest tonight, feel the sunlight still lingering on your skin. It traveled across the void, born in fire, shaped by time, arriving just in time to warm you. Light, like kindness, can travel far and arrive when it's needed most. 75. There are more trees on Earth than stars in the Milky Way. When we gaze into the night sky, the Milky Way's countless stars stretch overhead in quiet majesty. We often feel small beneath their glow. But here on Earth, another kind of wonder quietly surrounds us. Trees. And believe it or not, there are more trees on Earth than stars in our galaxy. Estimates suggest the Milky Way contains between 100 and 400 billion stars. Yet, a 2015 study published in Nature found that Earth is home to approximately 3 trillion trees. That's over 7 times more trees than stars in our galaxy. These trees cover mountains, valleys, rainforests, plains, and tundras. They form forests that breathe, absorb carbon, offer shelter, and sustain life. Each one is a world unto itself, home to countless creatures, growing silently over decades or centuries. This fact reminds us that awe isn't limited to the stars. It's rooted in the soil, whispered in leaves, and scattered in seeds. Earth itself is a miracle of abundance. As you drift to sleep, let that thought settle over you. Beneath the stars, more than 3 trillion silent guardians stand watch. The universe inspires wonder, but so does the home beneath your feet. Out there, the stars continue to shine. Galaxies drift quietly through time, and the universe carries on. Vast, beautiful, and peaceful. Thank you for sharing this time among the stars. Rest well, dream deep, and remember, you are part of something infinite. Good night, traveler.